Okay, continuing on with the Unit 4B review. We left off, we are solving by square roots. So we want to get x squared by itself, so we need to subtract 50. Then we need to divide both sides by 2. All right, so we have x squared by itself. We want to get rid of the exponent. We square root both sides. So we got x equals. Now we got to be very careful here. Remember to throw in your plus minus for your two answers. Now there is a negative inside the radical. Remember, an I comes out of the radical. And then the square root of 25 is 5, so we would call it 5i. Let me clean that up a little bit. Plus minus 5i. So remember the rule, when you have a negative inside of a square root, an I has to be pulled out of your radical. And by the way, there is no radical remaining because it works out 25 is a perfect square. Okay, next up, solve by the quadratic formula. So even though this formula is given to you on the test, it's always good to remember formulas. I find that the people who memorize them usually know how to use them a lot better. So there's the formula that I'm going to go over. Remember, for quadratic formula, we also want it equal to 0. So it's in the form ax squared plus bx plus c. So you can see the a is 6, b is 4, and c is 11. So let's go into our formula. So we start off with negative b, followed by plus minus. Then we have a big square root. Inside the square root is b squared minus 4 times a times c divided by 2 times a. So the way I taught you is you start off with 3, you're multiplying 3 times to start here, here, and here. So let's bring down our negative 4 plus minus square root of 4 squared is 16. Whatever that b squared term is, it's always going to be a positive out of that. Remember, whenever you square a number, it's positive. Followed by negative, I don't have a calculator on me, so 4 times 6 is 24 times 11 is 264. And on the denominator, 2 times 6, 12. Now we need to get the radical down to one number. So we always add or subtract whatever it shows in the radical. So 16 minus 264 is negative 248 over 12. Now, I do have to, when your radical is down to one number, you have to try to take out a perfect square, all right? Oh, you are going to have a negative here, so an I comes out. Sorry for mixing up my words. I was getting out a calculator while trying to speak. Not always good to multitask. So anyway, an I is going to come out. All right, we always remember that. When we have the square root of a negative, an I comes out of the radical. Now I got to worry about trying to reduce or simplify this radical. So I'm getting out a calculator and I'm going, okay, can I divide 248 divided by my perfect squares? I'm trying 64. No, I get a decimal. 64. Now I'm going to try dividing by 36. 6. Nope, that got a decimal also, 25/16. Now I'll try divided by 16. Still got a decimal. 9, 4. Now I'm going to try 4. Obviously, that's going to work. And get 62. So the square root of 248 can be split up into square root of 4 times the square root of 62. So now this square root of 64, you will square root it, of course, and it becomes 2. So let me carry this over. So if it's a 2 pulled out with an I, we'll call it 2i. Get it in the right order. You wouldn't write I2, you'd write 2i. And then drag over the square root of 62. Now after that, it does get very tricky. This is a fraction after all, and we do like to reduce fractions into math, of course. So we look at 3 numbers. Actually, I'll make it easier on you guys. Here's what you want to do. You want to split it up into 2 fractions. -4 over 12 plus minus 2i root 62 over 12. Just make it 2 separate fractions. And then reduce each of the fraction. -4 over 12 is -1/3. Carry over your plus minus. 2 over 12 is 1 over 6. You don't need the 1 up there, though, because the I root 62 is there. And there's your answer. Okay, another Pythagorean theorem. A is 1. It is set equal to 0. I did check that. A is 1, B -6, and C is -7. So negative B, but the B is a negative, so that's double negatives to become +6, plus minus square root of B squared minus 4 times A times C divided by 2 times A. So I'm going to multiply 1, 2, 3 times. So -6 squared is 36. And then multiply -4, double negatives plus, and 28. And on the bottom, 2 times 1. In the radical add, get the square root of 64. And now we're going to try to simplify that radical. So the square root of 64 is 8. So this is going to be a little different than the last problem. The last problem we still had a radical in our answer. This one we will not. We are going to get 2 distinct answers. So you need to split it up and get those 2 answers now. So you'll have 6 plus 8, then divide by 2, and 6 minus 8, then divide by 2. We're splitting up the plus minus. So 14 over 2 is 7, and -2 over 2 is -1. Easy stuff, just gotta put in the work. Okay, 15. Don't be intimidated. It's actually pretty easy. We're missing an x term, so just write it in as a 0x. So the a would be 1x, the 1, b would be 0, c would be 8. Now we can go to our formula. -b plus minus b squared minus 4 times a times c divided by 2 times a. So let's work. Let's do our routine. Multiply our 3 times. 0 squared is 0. Multiply to get -32. And on the bottom, 2 times 1, 2. And then add or subtract. So in the radical, it'd be square root of -32. And now let's start simplifying that radical. And I must come out because we have square root of a negative. And then we're going to worry about breaking up that square root of 32. The square root of 32, you got to think of a perfect square that goes into it. 4 is a perfect square that goes into it, but there's actually a bigger one. It's 16. So we actually have to think of the biggest perfect square that multiplies evenly into it. So it breaks up as square root of 16 times the square root of 2. So then we square root the 16 to have 4. So outside we have 4i. Drag over your square root of 2 over 2. Now we want to clean this up a little bit. Since there's a 0 out in front for b, we can just get rid of it. And then it's actually down to 1 fraction. And we want to reduce that fraction. 4 divided by 2 is 2. And drag over your I root 2. So we have two answers here, 2i root 2 and negative 2i root 2. And last one for quadratic formula. Throw in a 1 there for a. So x equals negative b plus minus square root of b squared minus 4 times a times c divided by 2 times a. So let's do our multiplication here. 1, 2, 3. 5 squared is 25. And then minus 4 times 1 times 7 is minus 28. The bottom 2 times 1 gets 2. Then we can subtract in the radical to get square root of negative 3. And we do have a negative in the square root, so an I comes out. And the square root of 3, can I simplify it? No way. And this fraction can also not be reduced. So this ugly thing is your answers, and that's done. Okay, next up we are going to go into simplifying complex expressions. It's not going to directly tell you. You got to be able to recognize if it's add, subtract, or multiply. There is no sign between the parentheses here, so remember that's multiply. So 5i times 4i is 20i squared. And then 5i times minus 3 would be minus 15i. We learned during that lesson that I squared is equal to negative 1. So this becomes 20 times negative 1, which is negative 20. And then bring down your minus 15i. Do not combine them. They are not like terms, so we stop there. Remember, you can only add or subtract like terms. This guy, a lot of people accidentally FOIL it because they see two binomials. No, it's a million times easier than that. We have a minus sign in between. So we are literally just subtracting like terms. So just do 2 minus 4 to get negative 2. And then do 3i minus 7i to get minus 4i. And then stop there. You cannot subtract them. They're not like terms. Done. All right, I'm going to stop this video. Part 2 is done. I'll continue with part 3 shortly.